रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़्दतम मिन लिसानी यफ़क़हू क़ौली। सुब्हानल्लाहि वल्हम्दुलिल्लाहि वला इलाहा इल्लल्लाहु वल्लाहु अकबर वला हौला वला कुव्वता इल्ला बिल्लाहिल अलिय्यिल अज़ीम। अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मद कमा सल्लैता अला इब्राहीम व अला आलि इब्राहीम इन्नका हमीदुम मजीद। Okay, in this video, we will calculate the time for a body to travel while sliding down on a parabolic path, on a parabolic curve. Y is equal to fx is equal to ax square. Okay, so this video is very similar to my video 23. So if you don't understand anything in this video, you can go back to video 23 and check the missing portion. Okay, so conditions are pretty similar to the ones in my previous video 23, except that this force has been added, mv square over r, the Tahirian centrifugal force. Okay, so when the body slides down, this is the body. When the body slides down, this is mv square over rho. When one of the mechanical forces are, the reaction here is in the direction of the center of curvature, which is somewhere here, then when one of the mechanical forces R is in the direction of the center of curvature, then R becomes the centripetal force, because it is headed towards the center of rotation here. When this mechanical force takes the position of this inertial force mv square over rho, then this gets replaced by R, and this gets activated as Tahirian centrifugal force, mv square over rho, where rho is the radius of curvature of the curve at that point, at that instant. Okay, so it's like this. The body is going like this. So this force, this is R. This force is mv square over rho, and there's so this is the combination regarding the couple. This one, and there is another force acting mg cos beta, which is the component of the center of gravity, or I mean the component of the force acting on it by the earth. Okay, so similarly mg sin beta is the component of the force of gravity in this direction, tangential to the motion. Okay, so this is tangential direction, this is normal direction. This normal direction is the direction of R, or perpendicular to it at that point. Okay, so it's like this. This couple we will use in 3 dimensions. This is also mv square over r, but we will, when we solve problems in three dimensions, then we will use this couple as well in a remarkable manner. Okay, so as in my video 23, this point is A, 2 pi x coordinate, and y 4 coordinate, where this 4 is actually 2r, where r is the radius of the generating cycloid, the radius of the circle rolling to generate the cycloid. Because eventually in my next video I'm going to compare this time 2.67 with the time of the cycloid. We will run the same procedure for a cycloid. Okay, but for this video the curve is y is equal to ax square. Okay, for condition of sliding at point A, so this is the condition of sliding at point A. Same condition, tan of beta A is greater than mu. The tan is beta is the Tahirian angle, the angle that the tangent at the point of contact makes with the horizontal x-axis, positive x-axis. This is the tan of that angle. Tan beta A greater than mu. Okay, those of you who wants to run the other side, run the same experiment on the other side of the parabola, they should use tan beta is equal to minus dy by dx. Why? Because this angle beta is the same as this angle beta. This angle beta is not beta, it's minus beta, because this one is plus beta according to the rules. So this angle is minus beta, this angle is the same as this angle minus beta. So tan beta would become minus dy by dx, because tan minus beta is equal to minus tan beta. Okay. and dy would be negative, but dx would be positive. So if you make these changes all over, then you will get the same answer as this block is going down on the other part of the parabola here with a book. But you can see it gives the same answer. So just let's focus on this side of the picture. Okay. So we got on 6 forces acting on the free body diagram. In the free body diagram, 6 forces acting: mv square over rho, Tahirian centrifugal force, m dv over dt, Tahirian centrifugal force. Okay. Okay, it's like this. Okay, so this is another Tahirian center of rotation is here. When in primary gravitation, when the Tahirian centrifugal force breaks up into 2 portions, then it makes 2 centers of rotation, 2 Tahirians of center of rotation. Okay, so one is for this one, Tahirian center of rotation here. The second is here. Why? Because there is no friction, then the mechanical force is acting here in this direction. So the Tahirian center of rotation is here. So centrifugal force will act in the opposite direction. It will take the position of this one. This one will be, this inertial force will be replaced by mg sine beta, and this one will be replaced by m dv over dt, which is the same as net force that you call ma, net force. But it's actually in the opposite direction, in this direction. This of course is equal to ma, because a is dv over dt. But it acts not as a resultant force, it acts as a centrifugal force in the other direction, which is stronger concept. Net force, somewhere it is applicable, somewhere it does not solve anything. Useless, rubbish, garbage. But my concept of centrifugal force solve everything in the universe, in the 7 heavens and the 7 earth. You will see, you will witness it, inshallah. Okay, m dv over dt. So this is the centrifugal force here, Tahirian centrifugal force, Tahirian centrifugal force. Another couple of Tahirian centrifugal forces which we will use in three dimensions is this couple. When we do motion in 3 dimensions, then we will use that couple in a remarkable manner. Okay, so 1, 2, 3, 4, 5, 6. Tangential direction, normal direction. So summation of forces in the normal direction in Tahirian cosmology, systems are in equilibrium even under extreme conditions of accelerations. Okay, so summation of forces in the normal direction is equal to 0 r minus mg cos beta minus mv square over rho is equal to 0. Ft is equal to 0 mu r plus mdv over dt minus mg sin beta is equal to 0. So from here you get dv over dt is equal to g sin beta minus mu cos beta minus mu v square over rho. So this is equation 1. Okay, so break up this into by using the differential ds, the differential of arc length, as in my video 23. dv over ds, ds over dt as usual, g sin minus blah blah minus this extra term minus mu, where mu is the coefficient of friction, which is 0.5 for calculations. But it should be less than the tan of this angle at this point. Otherwise there won't be any sliding. When you leave it here, it won't slide, because this is the condition of sliding at point A. Okay. So we also know that rho is equal to ds over d beta is equal to greater than, where beta is the Tahirian angle. In my previous video 23 I used phi. I don't know why I used phi, but actually it's Tahirian angle. It's the same angle that is used in primary gravitation. Tahirian angle is the same one that is used here. Okay, so we also know that rho is equal to ds over d beta. So ds over rho is equal to d beta. Rho is the radius of curvature, ds is the arc length of differential line element or differential arc length, and beta is this Tahirian angle, which is the same as the angle here of the sector that is constructed by using the radius of curvature. Same angle, same angle. So it's like the formula S is equal to r theta. Simple formula. Okay, so v dv is equal to minus gv g dy. Okay, so here we put minus dy minus dx. Check it in video 23. Okay, so you get this blah blah blah. Okay, so what here I did something just to explain it. So I added beta and subtracted beta. It doesn't make any big difference. It cancels out. Okay, just to show you that this v square plus beta minus beta is basically a function of v and beta. Just to make it, to show you that it is a function of two variables. So similarly, you can write this one as u function v comma beta d beta. Okay, now you know that when you integrate a function of two variables, but it is an explicit function, like it's z is equal to f x y, where z is an explicit function of x and y. With respect to any variable, if you integrate an explicit function, now nature is explicit and so is the function f v comma b. Okay, our nature has provided us with explicit functions, explicit values that describe our secondary gravitation, our physics on the surfaces of planets, and the primary gravitation of the binary star systems. Okay, so whenever we integrate a function, an explicit function of two variables with respect to one variable, we hold the other variable as constant, even though it's not a constant. Okay, now nature is explicit and so is the function. Okay, so when we integrate, we get mu v square beta. Very simple, beta. Plus c, where c is the constant of integration, blah blah v square. You bring this term here and you add up here, and then you get c. Applying boundary condition at release point A. This is the release point A, x a y a. Later we will put its values 2 pi and 4 here to get the answer for a particular case. I mean, not a decorative case. I mean the real answer, the real values. Applying boundary condition at release point ax a, velocity is 0 at the release point. When we release this box here, the velocity is 0. At x a, then we get the c value of minus 2g ax a square, which is y. This is ya. Ya is equal to ax a square minus mu x a. 1 plus 2 mu beta, this term. Okay, so v is equal to minus 2g y minus mu x plus 2g y a minus mu x, where beta is equal to tan inverse dy by dx here. Okay, blah blah blah. Okay, so the time is given by ds over dv minus x a, because the differential, the variable in the differential is x, so x a to 0. For minus sign, please watch my video 23. Why I put the minus sign here, I have explained it in my video 23, so you can understand it. Watch it and understand it. X a to 0, because the initial x coordinate is x a, the final is 0. So x a to 0, 1 plus mu, put the value beta here, tan inverse dy by dx. Okay, so for lot of curves, almost infinite, you can plug in the values and calculate the time. But care should be exercised that the concavity should be like this. It should not be like this, because it changes the whole scenario. Okay, so all curves which are symmetric with respect to y-axis and they go like this, you can use this formula and get the result. Okay, now we will apply this to our particular points. For x a y a is equal to 2 pi meter, 4 meter. Y is equal to ax square for a distance of less than 7.45 meter. You can check my video 23. So y is equal to ax square, you put the value of this, then you get the value of a 1 over pi square. Okay, so dy by dx is 2x over pi square. Okay, take the derivative, 2x over pi square. Okay, mu is, as in the previous video, mu is 0.5 and the gravity g is 9.81 meter per second. So you insert the values here. 1 plus tan inverse 2x over pi square plus 1 plus 4x square over pi 4 minus blah blah blah. You get this one, then you get this, you get a quadratic equation here. So when this is